detailed pass 1 of assembler. You can see here the one which is in black is common for both the flowchart, whether it is pass 1 or pass 2. Pass 1, location counter is initialized to 0. Read, pot, mod, length of instruction here. Pass 2, location counter is initialized to 0. Read, pot, mod, length. Here, if pseudo opcode is found, which one? It has been segregated here. DC, DS, declarative pseudo opcodes, EQ view, using drop, the one which is used for base register, end. Which one? Same thing. DS, DC, EQ view. You are dividing it individually here. EQ view using drop and end. Now, the one which I have written in red color is the difference. Pass 1 has different, pass 2 has different options. So from length type of the instruction, literal, we are checking with literal, storing the literals in literal table. If it is a symbol, assign current value and store it in symbol table. Increment location counter, make a copy of the source program. Write function is used to make a copy of source program and store the same for later use. Then once you are done with this, you will be going to read next instruction that I have to do. Now DC, DS and DC, define constant, define storage, adjust location counter, determine the length, then connect it to symbol table. Eval, EQ view, evaluate the expression, then assign storage, what value, what is the variable, what is the value you are trying to assign, store it in symbol table, and directly you can go to write function. Using and drop we are not using in pass 1 of assembler, so directly we are moving on to pass 2. Directly it is been moving to write function. End, literal assignment is done. Reset and rewind, go to pass 2. This will complete your detailed pass 1 flowchart. When you are switching on to pass 2 flowchart, the top thing is similar to pass 1 of flowchart. Then here, when it comes to length, type, opcode, format of the instruction has to be known. Then types of instruction. There are 5 types of instruction format. You have to remember that: SS, RS, SI, RR, RX. Mostly we are using most of the time RX and RR, SI. So that is what we are trying to expand that particular thing in detail. RR, register, both the operands are stored in register. So we are evaluating what is the operand stored in the register. So only once I have written eval, both the operands will be evaluated. Whereas RX, eval twice, one for register operand, one for storage operand. In order to find out storage operand, contents of base register, content of index register, then content of plus displacement will give you the memory location. So I need to know which is the base register, BT get, put B and D into byte 3 and 4. Then connect it to punch. Punch is again a function which will be making a code in the form of punch cards. Print is again a function printing all the necessary things for the process of assembler. Then increment location counter. Alpha is recognized as print. Read is recognized as beta. So towards beta means it will go to read. Wherever you are writing alpha, it will go to print. So here, which one? All the pseudo opcodes individually you have to write. DS, DC. Adjust location counter, it's the same. Now here again we are checking whether it is DC or DS. If DC is found, you are going for DC generation of that. If DS is found, determine the length of the space required and move on to alpha. Go to print and increment location counter each time. Then if it is EQ view, already it is been processed in Pass1. So directly you are going for print. Then same thing, if it is using will indicate which is the base register used in your program. So you need to evaluate it. Store the base register, BT store, print, go to beta. Then drop, you need to make that particular register as unavailable. Suppose I am using register 15 as a base register. Now I don't want to use it. So drop, BT drop, end. Literal assignment is done in Pass1. Literal generation is done in Pass2. Then stop, exit, stop or exit in Pass2. Then after location counter again has to be connected to read. Read the next value. So this will complete your detailed Pass1 and Pass2 of